Good morning everybody. In my previous class, we have started discussing alkenes. In that connection, we have started this method of preparation. One method I have taught you, that is dehydration of alcohol, and another is dehydrohalogenation of alkyl halide. There, a rule is there, XII's rule. XII's rule. Now, which states that when a secondary or tertiary alcohol is dehydrated or when a secondary or tertiary alkyl halide is dehydrohalogenated, you will get an alkene which is more alkyl substituted. I have given you example in case of 2-butanol or 2-haloalkane, you can get butene. You see, already we have discussed it. This is but1en. Also there is chance that you can get but2en. Both the products will be formed, but so far XII's rule is concerned, you will get but2en about 81% and but1,1-en, this is 19%. Why? Because you see this is your functional group. It contains only one alkyl group, but here two alkyl groups are there. According to XII's rule, you can get an alkene which is more alkyl substituted. Therefore, but2en will be predominant product than but1en. Next method is by dehalogenation of this dihalide. Your dihalides are of two types. Dihalides. One is called Chem dihalide. Here, two halogen atoms are attached to same carbon atom. The second one is this dihalide. Here two halogen atoms are attached to two adjacent carbon atom. X stands for halogen, maybe fluorine, chlorine, bromine or iodine. So when we are taking this dihalide heated with zinc dust, it gives you alkene, say RCHX. When you are heating with zinc powder, Zn react with here. One molecule of zinc halide is eliminated, giving you alkene. Next method is Kolb's electrolysis. I have told you earlier, Kolb's electrolysis is a general method for the preparation of alkane, alkene and alkyne. We have already discussed Kolb's electrolysis in connection with alkanes. For preparation of alkyne, when you are taking a saturated aqueous solution of either sodium or potassium salt of a dicarboxylic acid on electrolysis gives alkene. Let us take one dicarboxylic acid. This compound is your, I am writing its common name, is a succinic acid. When you are taking its potassium salt, it is your potassium succinate, potassium succinate. Electrolysis is a reversible process. On electrolysis, you are getting succinate ion and potassium ion. This is your succinate ion. So, potassium ion goes to cathode. So, reaction at cathode, potassium ion add up with the electron gives you 2 potassium metal. Potassium react with water gives you potassium hydroxide, and hydrogen gas will be evolved at cathode. Reaction at anode, your succinate ion goes to anode. Here 2-step reaction. In first step electron is removed, second step carbon dioxide is removed. So, you are getting ethylene, common name, or ethene. The carbon dioxide will be arrested by potassium hydroxide to give you potassium carbonate and water. So, this is another method for the preparation of alkene. Next method is by partial I mean partly, partial hydrogenation of alkyne. Alkynes possess carbon-carbon triple bond. When it partly hydrogenated, you will get double bond. If it completely hydrogenated, it will form carbon-carbon single bond. Here, alkene is either treated with hydrogen in the ratio 1:1, taking nickel as a catalyst between 200 to 300 degrees centigrade, or you can use platinum or palladium at 25 degrees centigrade. So, alkyne we shall have to take C triple bond C, sorry. So, it will partly hydrogenated because hydrogen amount is less. So, it will form alkene. Or another method, when you take hydrogen excess, it will use Lindlar's catalyst. I will tell you what is Lindlar catalyst. Here the reaction will take place only one step, when you will get alkene. So, either this is your alkyne, this is alkyne. There are two methods. You can take hydrogen control its amount to ratio 1:1. In presence of nickel catalyst 200 to 300 degrees centigrade or platinum palladium at 25 degrees centigrade will give you one step reaction alkene. Or you can take excess hydrogen, no doubt, but using Lindlar's catalyst all the reaction will be only one step. Your Lindlar catalyst is palladium. It is deactivated. It is deactivated by using quinoline or quinoline or salt of heavy metals, so that reaction will be only one step reaction. So these are the few methods of preparation of alkenes. Next we shall proceed their chemical properties. Since it is an unsaturated hydrocarbon, it will exhibit addition reactions. Addition reactions. Number 1, addition with hydrogen. We can call it hydrogenation. When alkene is hydrogenated by using hydrogen, nickel as a catalyst between 200 to 300 degrees centigrade or platinum palladium at 25 degrees centigrade. It will form a single bond compound, that is alkane. This is your alkene saturated to form alkane. Number 2, addition with halogens, say X2. X can be fluorine, chlorine, bromine, etc. When you take an alkene, halogen is reactive elements. It can be fluorine, chlorine, bromine or iodine. It will form a dihalide where you can find 2 halogen atoms attached to 2 adjacent carbon atoms. So this is your bis dihalide. Now, both hydrogen and halogens are symmetrical molecules. Symmetrical means when divided you will get same, both the parts same. Number 3 important, addition with hydrogen halide, say HX, let me take HCl. Now, here let me take ethylene first. Ethylene is a symmetrical molecule. Symmetrical means the carbon atom having double bond contain equal number of hydrogen atoms. So when HCl is added to it, either chlorine can attach to this carbon atom or other carbon atom, though it looks like different compound, but they are the same compound. This is 1-chloroethane. This is 1-chloroethane. So HCl is an unsymmetrical, gives you H plus Cl minus, but when it is added to ethylene, which is a symmetrical molecule, we are getting only one product. But if you are taking propene, which is an unsymmetrical molecule, unsymmetrical I mean the carbon atom having double bond possess unequal number of hydrogen. When we add with hydrogen chloride, there can be 2 possible products. Either you can get this compound or that means chlorine can attach to first carbon atom or to the second carbon atom. This is your 1-chloroethane. propane, this is your 2-chloropropane. Then which compound will be formed? This is being decided by a rule which is called Marconi-Kopf's rule. When Marconi-Kopf's rule asks as a short note, you write, when an unsymmetrical molecule is added to an unsymmetrical unsaturated hydrocarbon, the addition product form is according to Marconi-Kopf's rule. According to this rule, the negative part of the additive reagent, sometimes called addendum, is attached to the carbon atom having least number of hydrogen. Here you can see between carbon atom 1 and 2, carbon atom 2 contain least number of hydrogen, that is the negative part Cl minus will attach to second carbon atom. Therefore, the product will be 2-chloropropane but not the 1-chloropropane. So, negative part of the addendum will attach to the carbon atom having less number of hydrogen atom. So, according to Marconi-Kopf's rule, when propane treated with HCl, it will give 2-chloropropane but not 1-chloropropane. However, when hydrogen bromide is attached to an unsymmetrical molecule in presence of an organic peroxide, peroxide means there will be oxygen linkage. It will give when it is in presence of an organic peroxide, the negative part, that is bromine Br minus, will attach to carbon atom having more number of hydrogen. So, here if we are taking bromine added with hydrogen bromide, which gives you H plus Br minus, in presence of organic peroxide, now the Br minus will be attached to first carbon atom which contain more number of hydrogen. So, you are getting 1-bromopropane. So, this is called what is peroxide effect, or sometimes we call it anti-Marconi-Kopf's rule. Only HBr, nothing, no other hydrogen halides. When HBr attached to an unsymmetrical molecule only in presence of organic peroxide. If no organic peroxide is there, the reaction will be as per the Marconi-Kopf's rule, but in presence of organic peroxide, the negative part here, the Br minus, will attach to carbon atom having more number of hydrogen, so that you will get 1-bromopropane. This is called peroxide effect or anti-Marconi-Kopf's rule. The fourth addition is very important, fourth type of addition. So, first, second, there is no rule, it is symmetrical. Third, Marconi-Kopf's rule is applied. Fourth one is ozonolysis. It is a two-step process. In first step, there is addition of ozone, and in the second case, subsequent hydrolysis of the ozonide so formed. So, ozonolysis is a two-step process, addition of ozone and subsequent hydrolysis of the ozonide so formed. Now, ozonolysis of alkene gives you same aldehydes, different aldehydes, same ketones, different ketones, or aldehyde and ketone mixture. So, you will get varieties of product on ozonolysis of different alkenes. It can give you same aldehyde, different aldehydes, same ketones, different ketones, or aldehyde ketone mixture. I am illustrating it with examples. Let us take ethylene or ethene. When ozone you are treating across the carbon-carbon double bond, one molecule of ozone will add up this is the ozonide. Now, when it is subject to hydrolysis by using zinc dust plus steam, this ozonide will break up. The dotted line is breaking line. Oxygen is taken by zinc oxide. Both the sides same, that is 2 molecules of CH2O. This is same that of 2 molecules of HCHO. This is your formaldehyde or methanol. If we are taking propene, when treated with ozone, now across the double bond I have told you, one molecule of ozone will add up to form corresponding ozonide. When it is hydrolyzed by using zinc dust in presence of steam, the carbon-hydrogen bonds and oxygen-oxygen bond breaks. So, one of the oxygen atom taken by zinc oxide, this side is CH3CHO and this side is HCHO. This is your ethanol, this is your methanol. So, you are getting two different aldehydes. In the first case, you got same aldehydes. So, you can get same aldehyde or different aldehyde. Here, if you take this compound, which is 2,3-dimethyl but 2-ene. When it is treated with ozone, as usual, across the carbon-carbon double bond, one molecule of ozone will add up. Now, when it is subjected to hydrolysis by using zinc dust plus steam, this carbon-oxygen and oxygen-oxygen bond breaks. The one of the oxygen atom already I have told you is zinc oxide. You can see both the sides same, CH3CO, CH3, this is your propanone, 2 molecules of propanone, that is same ketone you are getting. But if you take this, this is also one of the alkyne, 2,3-dimethyl pent 2-ene. When it is subjected to ozonolysis, first step, add ozone, across the carbon-carbon double bond, as I have told you. One molecule ozone is added where there was carbon-carbon double bond. When it is heated with zinc dust and steam, here carbon-oxygen bond and oxygen-oxygen bond breaks. One oxygen atom taken by zinc, giving you zinc oxide. This side you can say CH3COCH3. This is your propanone, and other side is CH3CO, CH2CH3. This is butanone. So you are getting two different ketones. One is propanone, second one is butanone. If you take this compound, this is your 2-methyl but1-en. Now, if it is subjected to ozonolysis, across oxygen molecule is added. So you can see this is the ozonide form, oxygen atom taken by zinc. This side is CH3COCH3 gote, one of the ketone, that is propanone, and the other side you can see CH3CHO, that is aldehyde ethanol. So I have given you 5 examples of ozonolysis where you can find ozonolysis of alkene can give you same aldehyde, different aldehyde, same ketones, different ketones, or aldehyde ketone mixture. So this is all about the addition reactions. Number 1, addition with hydrogen, addition with halogen. But when addition with hydrogen halide or an unsymmetrical molecule is added to an unsymmetrical unsaturated hydrocarbon, the addition product form governed by Markovnikov's rule. According to Markovnikov's rule, the negative part of the additive reagent will attach to the carbon atom having least number of hydrogen. Only exception, hydrogen bromide, when treated in presence of organic peroxide, the bromine Br minus, which is negative part, will attach to carbon atom having more number of hydrogen. That is called peroxide effect or anti-Markovnikov's rule. Ozonolysis is very, very important. It can give you varieties of product. It can give same aldehyde, different aldehyde, same ketone, different ketones, or aldehyde ketone mixture. This is all about addition reactor. B is oxidation. Bit 1, your combustion. Already I have told you when any compound heated with excess of oxygen, say let me take ethylene, its carbon content it oxidized to carbon dioxide, hydrogen content oxidized to water along with evolution of heat. So during combustion process, oxygen is heated, excess oxygen, here alkene, the carbon content oxidized to carbon dioxide, hydrogen content to water along with evolution of heat. The second oxidation reaction is using an oxidizing agent like potassium permanganate, that is by using alkaline potassium permanganate. Here alkali is used when an alkene, in general I have taken an alkene, when it is subject to oxidation by using potassium permanganate along with the dilute alkali like sodium hydroxide or potassium hydroxide, two OH groups add across the carbon-carbon double bond giving you a dihydric alcohol. This is 2 hydroxide group are there, dihydric alcohol. In general, it is called glycols. Glycols. So you are getting 2 OH group attached to 2 carbon atoms having carbon-carbon double bond. Third oxidation is acid-fat potassium permanganate. This is important when it is treated with potassium permanganate in presence of, say, dilute sulfuric acid. Here you are getting 2 monocarboxylic acid by splitting carbon-carbon double bond. I am repeating, by splitting carbon-carbon double bond. So you will get 2 different monocarboxylic acid. Monocarboxylic acids. So these are the 3 different types of oxidation. One is combustion, second is by using alkaline potassium permanganate, third one by using acid fat potassium permanganate. C. Polymerization. Polymerization means same molecule is repeated for large number of times. Let us take a simple example, ethylene, N molecule, ethylene. When treated at high temperature, under high pressure, and in presence of catalyst, N molecules of it will combine to form what is called polyethylene. The value of N, how many molecules will combine, depends upon temperature, pressure and catalyst used. So, alkene can be polymerized to form polyalkene under high temperature, high pressure in presence of catalyst. Now, the how many molecules will combine depends upon temperature, pressure and catalyst. The last reaction is substitution. Substitution reaction normally is not given by alkenes because it is an unsaturated compound. It prefers addition reaction. Substitution reaction is the reaction due to saturated, but here only when propene treated with chlorine at a high temperature about 500 degrees centigrade, it gives you one substitution reaction, gives you 1 chloroprop 2En. Let us take propene. When heated with chlorine at very high temperature, so one first carbon atom hydrogen is replaced by, I am writing in a reverse way. This is here one hydrogen atom replaced by chlorine. That is substitution reaction. The name already I have written it, 1 chloroprop 2En. So, substitution reaction is not the characteristic of alkene, but this is an exception when propene at very high temperature, but at low temperature it will undergo addition reaction to give 1,2-dichloropropane. At high temperature, one of its hydrogen atom will be replaced by chlorine. This is all about alkenes. Next I am proceeding to alkynes. So far the general formula is concerned, it is CnH2n minus 2. So far the functional group is concerned, it contains carbon-carbon triple bond. Now the carbon atom having triple bond undergoes sp hybridization. Remember, this is important, hybridization. If it contains only single bond, sp3. If it contains double bond, sp2 if contain triple bond, sp hybridization. And alkynes usually undergo or exhibit position isomerism. Next we shall proceed to different methods of its preparation. Now, number 1, by dehydrohalogenation of dihalides. Dihalides you can take bis dihalides or Chem dihalide. This is I have taken bis dihalide. Already I have told you when two halogen atom attached to two adjacent carbon atom, when it is treated with alcoholic potassium hydroxide, the potassium hydroxide dissolve in alcohol. Two hydrogen halide is removed to giving you RC triple bond CH, that is alkyne. Hydrogen halide is acid, react with potassium hydroxide to give potassium halide and water. Similarly, if we take a Chem dihalide, under same condition, alcoholic AOH means potassium hydroxide dissolved in ethyl alcohol. It will also give you same alkyne, and hydrogen halide eliminated, which is a acidic nature, neutralized by potassium hydroxide, which is a base, to give you salt and water. So this is another one method of preparation. This is number 2, by dehalogenation of symmetrical tetrahalides. Symmetrical tetrahalide means 4 halogen atoms symmetrical distributed between 2 adjacent carbon atoms. That means 4 halogen atoms extends per halogen. Already I have told you fluorine, chlorine, bromine or iodine. When it heated with zinc dust, one ZnX2, ZnX2, 2 molecule of ZnX2 will be eliminated, giving you a C triple bond CH. So this is another method. Third method is Kolb's electrolysis. Kolb's electrolysis is a general method for the preparation of alkane, alkene, also alkyne. Now, in case of alkyne, you will have to take a saturated aqueous solution of either sodium or potassium salt of unsaturated dicarboxylic acid, unsaturated dicarboxylic acid. This compound on electrolysis gives alkyne. One such unsaturated dicarboxylic acid I am writing is CH, COOH. This compound common name is fumaric acid. Let us take its potassium salt, potassium fumarate, CH. This compound is potassium fumarate. Now, When potassium fumarate is electrolyzed, electrolysis is a reversible process. On passing electricity, you are getting fumarate ion plus potassium ion, fumarate ion. So, reaction will take place at cathode as well as at anode. Cathode, potassium add up with potassium ion, add up with the electrons, give potassium metal. Potassium metal react with water, gives you potassium hydroxide and hydrogen. At anode, fumarate ion, the reaction is two step. First step, electron is removed. Second step, carbon dioxide. You are getting here acetylene. Common name is acetylene. UPAC name is ethyne. The carbon dioxide will be arrested by the potassium hydroxide. As usual, it will not be removed, giving you potassium carbonate plus water. So, Kolb's electrolysis method is a common for preparation of alkane, alkene, alkyne. In connection of alkyne, you are taking saturated aqueous solution of either sodium salt or potassium salt of unsaturated dicarboxylic acid. I have taken potassium fumarate. You are getting alkyne, that is ethyne or acetylene in common name at anode, hydrogen at cathode. Carbon dioxide will be arrested by potassium hydroxide. It will not be eliminated. So, next method where you can get acetylene only, when calcium carbide treated with water gives you acetylene. Calcium carbide hela CaC2 on treatment with water, it gives you acetylene plus calcium hydroxide. Remember, there are two carbides. One is aluminum carbide, which on treatment with water gives methane. Already I have told you in connection with alkane. This is calcium carbide treated with water gives you acetylene. When iodophore is heated with metallic silver, it will gives you acetylene also. This is iodophore, CHI3. Here 6 silver atom on heating gives you 6 molecule of silver iodide plus acetylene. So, these are the few methods of preparation of alkynes. Next we shall proceed to its chemical properties. As usually it will undergo addition reaction because it is an unsaturated hydrocarbon. Addition with tetrahalide. Third reaction with addition with hydrogen halide. Here, as usual, Markovnikov's rule will be applied. Now, if I are taking say symmetrical molecule, say CH triple bond CH acetylene, if I are treating with say hydrogen halide H plus Cl minus. So, in the first step, molecule is symmetrical, no Markovnikov's rule will be applied. So, you will get CH2 double bond CH, Cl. This is chloroethene, but after this step, if we are adding HCl, Mr I am writing for Markovnikov's rule. Here you can see the molecule become unsymmetrical, 2 carbon atom having double bond, one contain 2 hydrogen, another 1 hydrogen. So, the negative part will attach to having 1 hydrogen atom. This is a 1,1 dichloroethane, which is a Chem dihalide. Chem dihalide, already I have told you, 2 halogen atoms attached to same carbon atom. But if we take starting with this is an unsymmetrical molecule. If we take any alkyne, say H plus Cl minus, here Markovnikov's rule will apply from the beginning because the molecule is unsymmetrical. So, again on treatment with H plus Cl minus, you are getting X. This is a Chem dihalide. MRI stands for Markovnikov's rule. So, addition with hydrogen halide, both cases acetylene or any alkyne you are getting Chem dihalide, but I am writing this, giving this example in the first step, no Markovnikov's rule is applied because the original molecule is symmetrical. Next is fourth one, ozonolysis. As ozonolysis of alkyne is not very important. It not gives you much better product like alkenes, which gives you same aldehyde, different aldehyde, same ketones, different ketones, or aldehyde ketone mixture. However, I am giving one example. If you take acetylene, here one bond remain because it has got triple bond. Now, this ozonide so far, when heated with zinc dust and steam, this carbon oxygen bond breaks and this oxygen bond. Here water, that is steam, takes oxygen, gives you hydrogen peroxide, giving you CHO. This is your glyoxal, which is a dihalide. This hydrogen peroxide form here, which is an oxidizing agent. This aldehyde oxidizes to a dicarboxylic acid. This is your oxalic acid. So, when acetylene is ozonolide, you can get oxalic acid. However, this oxalic acid when heated, it can give you formic acid plus carbon dioxide. So, the yield is not better so far the ozonolysis of alkynes is concerned. So, I have compared with alkene. There are 4 different type of addition. Addition with hydrogen, addition with halogen, addition with hydrogen halide. If molecule is unsymmetrical, Markovnikov's rule will be applied. Ozonolysis of alkynes does not give much better product. Next, oxidation. Here only one reaction I am discussing, that is combustion. Already I have told you any hydrocarbon like say acetylene, when heated with oxygen, carbon content will be converted to or oxidized to carbon dioxide, hydrogen content will oxidize to water along with the evolution of heat. The third category of reaction is polymerization. Here also I am taking only one example. When acetylene, which is a gas, when passed through heated copper or iron tube, 3 molecules of acetylene polymerizes to form benzene, heated copper or iron tube. Here you will get benzene. Or you can write benzene. Now here I am taking 3 molecules of acetylene, which contain carbon-carbon triple bond. One bond comes here, forms a single bond, another bond comes here. So when it is passed through heated copper or iron tube, 3 molecules of it polymerize to form benzene. So this is regarding polymerization reaction. One reaction which is not given by alkene but given by alkynes when treated with acidified mercuric sulfate. Acidified mercuric sulfate. Now, when acetylene treated with acidified mercuric sulfate gives an aldehyde, but the rest of the alkynes gives ketone. Now, acidified mercuric sulfate here is 10% mercuric sulfate mixed with 1% sulfuric acid. This is your acetylene. Here 2 ions add, H plus OH minus, but here you see molecule is symmetrical, no Markovnikov's rule is added or applied here, so you are getting OH group attached to one carbon, H plus attached to another. This common name is vinyl alcohol. This is unstable, undergoes a rearrangement reaction in which one hydrogen atom changes its place to form acetaldehyde. So acetylene, the first member gives you acetaldehyde. If you are taking any other alkyne in general, when treated with acidified mercuric sulfate, which is a 10% mercuric sulfate along with 1% sulfuric acid, here H plus OH minus produced will add up according to Markovnikov's rule because molecule is unsymmetrical. So you are getting RCOH CH2. This is unstable, undergo rearrangement reaction to stabilize it. Rearrangement reaction, one hydrogen atom moves from one place to another. So you are getting in ketone. So if you are taking acetylene, gives you acetaldehyde. If you are taking any other alkyne, you will get ketone. So these are the different reactions of alkynes. Next part, how to distinguish between alkane in one hand, alkene, alkyne, which are unsaturated hydrocarbon in another hand. Distinction between, from alkane I am taking one example, ethane. Distinction between ethane and another one, that is ethylene or acetylene. So this is saturated hydrocarbon. This is saturated hydrocarbon. These two are unsaturated hydrocarbon. Now let us take bromine water. Bromine mixed with water called bromine water its color is yellow brown. Yellow brown. When ethane pass through bromine water, no reaction takes place. No reaction. Therefore, the color remains as yellow brown. No change in color. Yellow brown color remain. Since there is no reaction of alkane or ethane, here I have taken one example with bromine water, the yellow brown color remain as such. But when ethylene say is passed through, ethylene, let us pass through bromine water, bromine will adapt so to form you dibromo compound, 1, 2 dibromo ethane. Since bromine is used up, the color become decolorized or yellow brown color become colorless. So it decolorizes the yellow brown color of bromine water, or we can call bromine water color is discharge. Color of bromine water is discharged. The color become colorless. Similarly, if we take alkyne, say acetylene, it will pass through bromine water, the reaction will take place, two-step reaction. Again it will form. Ultimately you are getting 1, 1, 2, 2 tetra bromo ethane. So in both the cases there will be decolorization of yellow brown color, that is. So this is very easy way to distinguish between alkane, I have taken ethane, from alkene or alkyne, that is from ethylene or acetylene. That is bromine water color will be decolorized. Now the question is how to distinguish between alkene and alkyne, because you cannot apply this easy method of bromine water because both of them will decrease. So distinction between say ethylene, one of the examples of alkene, and acetylene, alkyne. Now acetylene possesses acidic hydrogen atom. Acidic hydrogen atom means the hydrogen atom can be replaced by metal. Hydrogen can be replaced by metals. Here carbon undergoes sp hybridization. So it possesses 50% S character. Therefore, the hydrogen atom in acetylene is acidic in nature. Acidic means the hydrogen atom can be replaced by metal. So I am writing 3 different reactions where you can find these reactions are given only by alkyne, that is acetylene, not by ethylene or alkene. Reaction with metallic sodium or sodamide, NaNH2 sodamide. So in acetylene gas is passed through heated metallic sodium or soda might the hydrogen atoms replace stepwise to give you CNA, or you can get CNA, the hydrogen atom replaced by metals. This is your mono sodium acetylide, or this is your disodium acetylide. Here both the products are colorless. So here hydrogen atom of acetylene is replaced by sodium. Number 2, action with ammoniacal cuprous chloride. Cuprous chloride is a dimer Ca2Cl2 mixed with ammonium hydroxide. Now when acetylene gas is passed through ammoniacal cuprous chloride, here the hydrogen atoms are replaced by metallic copper Cu2Cl2 plus ammonium hydroxide. 2 hydrogen atom replaced by copper. HCl is formed, HCl react with ammonium hydroxide to form ammonium chloride and water. This is a solid. This is your copper acetylide, which is a red brown precipitate. So easily you can use this test to distinguish between ethylene and acetylene. Ethylene will not respond to this reaction, whereas acetylene will give a red brown precipitate of copper acetylide when passed through ammoniacal cuprous chloride. Third, action with ammoniacal silver nitrate. Here silver nitrate mixed with ammonium hydroxide. When acetylene gas passed through ammoniacal silver nitrate, here silver nitrate mixed with ammonium hydroxide, the hydrogen atoms replaced by metallic silver, giving you silver acetylide. Ammonium hydroxide react with HNO3 to form ammonium nitrate plus water. This is a solid. Its name is silver acetylide. This is white precipitate. So this reaction can be also utilized to distinguish between ethylene and acetylene. Here, these two, if it is asked to distinguish between ethylene and acetylene, write a reaction 2 or 3. With ammoniacal cuprous chloride, you are getting copper acetylide, which is a red brown precipitate. With ammoniacal silver nitrate, you are getting a white precipitate of silver acetylide. One intelligent question I am giving to you. Say if you get butane and this is but1YN, this is but2YN. Which of them respond all these 3 reactions, or both of them respond, or none of them respond? Now this compound responds since it contains an acidic hydrogen atom, that is carbon atom having triple bond, contain acidic hydrogen atom, but here no hydrogen atom is there. Therefore, but1yN will respond the ammoniacal cuprous chloride, reaction with ammoniacal cuprous chloride, or ammoniacal silver nitrate, or metallic sodium or sodamide. So, this is all about today. Thank you.